Okay, we're starting on chapter 11, and again, it's going to be broken up into 3 parts. So chapter 11 is all about running water, and this picture is showing the Nile River, and the Nile River is the longest river in the world. If we look at percentages of water, what we find is that about 97% is in the oceans. So most of our water is in the oceans. 2% is in glaciers, and then the remaining percentage you can find in the atmosphere as groundwater, water that's in lakes and swamps and bogs and streams and rivers. One of the important things to learn about water is what's known as the hydrologic cycle. That shows us the continuing recycling of water. Everything starts with the ocean. We have evaporation of water from the ocean, and that moisture is carried up into the atmosphere. Now, eventually that moisture has to fall back on Earth. It can fall in a number of ways. It could fall as precipitation. It could fall as ice, snow. It could fall as sleet. And then eventually what's going to happen is once that water falls on the land, it will either seep into the ground as groundwater. It can run off the slopes and run off and get funneled back to the ocean. It could undergo what we call transpiration, and that's when you have evaporation of the water from the surfaces of leaves. Or we might even have what we call sublimation, where basically you're going from a solid state directly to a gaseous state. So in terms of fluid flow, fluids are classed as any liquids or gases. When you look at a fluid, they have no strength. They flow in response to a force. One thing you want to notice and keep in mind is something we call infiltration capacity. That's the maximum rate at which that soil or sediment can absorb water. So it's going to be governed by the intensity and duration of rainfall. Are you dealing with thunderstorms? Are you dealing with drizzle over a period of time? You also have to take into account what type of soil are you dealing with. Is it loose and dry, in which case it's going to soak up the water very well? Or is it tightly packed and wet already, in which case it's not going to soak up that moisture? Depending on the infiltration capacity will affect how much actually runs off. So when you look at running water, you're basically talking about any surface water that goes from a high area to a low area. It's doing so in response to gravity. Running water is very effective as an erosional agent. It's also very effective in transporting sediment as well as sediment deposition. Now, the difference between sheet flow and channel flow is sheet flow, as you can see in this top picture, it's a continuous film of water, a continuous amount of water flowing over a surface. It is not constrained by any boundaries. With sheet flow, you're going to get sheet erosion. Channel flow, on the other hand, is where you have that surface water, but it's confined to that depression. And you can see in this picture, we have our flow coming down, and so our water is confined in that channel. An example would be the Mississippi River would be channel flow. The river is flowing within the channel banks. Now, the way those streams and rivers are going to receive water, it could be by sheet flow, it could be by direct rain. Also, soil moisture and groundwater are very important. Now, when you're talking about flowing water, you want to keep in mind the gradient, which is basically the slope of a stream, meters per kilometer. You also want to keep in mind the velocity, which is basically the distance traveled per unit time. Closer you are to the banks, the slower the velocity is going to be because of friction. It's also going to be governed by the shape of the channel and what kind of banks you have. And then lastly, you could look at the discharge, where you're looking at that volume of water passing a certain point in a given interval of time. Is the discharge more in the springtime or in the fall for given rivers, basically? And you can see in these diagrams or these pictures A, B, and C. So in A, you're looking at the gradient, which is again the slope. B, you're looking at the maximum flow velocity being near the center of your channel. The length of the arrows give you an indication on the velocity. And then C shows the 3 different channel shapes and which one has the greatest resistance to flow. Now, in terms of energy of the flowing water, we have both potential and kinetic energy. You might have heard of these 2 terms. So potential energy is your stored up energy, your energy of position. It's that energy that's just waiting to move. So water at your high elevations are going to have more potential in that they're just waiting to be released. Kinetic energy, on the other hand, is energy of position. Kinetic energy is energy of motion. So your potential energy is actually going to be converted to kinetic energy once that water starts to move. How do we transport particles? Well, 3 ways we can transport particles. We can have dissolved load, which we're not even looking at those particles. We can't see them because they're being transported as ions in solution. We have our suspended load, which are our small particles, silt and clay. They're kept moving by turbulence. If you go out to the Mississippi River and put some water in a beaker, it's going to be cloudy. If we let that beaker sit for a few days, it's going to be clear at the top and cloudy at the bottom because all of your suspended material will have settled out because there's no velocity, no turbulence in that beaker. And then we have our bed load, which is our bigger particles, mostly our sand and gravel. So these are going to either be transported along the bed, or we can think of it as this term saltation, which basically means, I have written down, intermittent bouncing and skipping. So basically what happens is one particle kind of moves and jumps in the air, it's going to hit another particle and it's going to move. Whereas our larger particles are only going to roll on the bottom, and they do so by traction. Now, we can have erosion and transport. We do it through hydraulic action, which is basically when I'm taking those loose particles and moving them by that moving water. We could also have abrasion, and abrasion is when your rocks are worn smooth by the impact of sediment, either through running water, through glaciers, waves, or wind. So these 2 pictures that you see in A and B, they're showing you what are known as potholes. Potholes are bowl-shaped depressions that are carved into the floor of the stream. It's basically done by a whirlpool carrying sand or gravel. So you can see in the first one are our potholes in the riverbed, and in this picture B, you're actually looking at a pothole viewed from the top. Okay, this ends part 1 of our